My concern has been about these mutations, and when I read about the first mutation rising out of Port Elizabeth, I knew deep in my heart that that township, in which there are very poor, underserved people living in tight quarters, it was very sad for me to hear of this evolution. And what amazing privilege we have had to hear from himself directly, Professor Tulio de Oliveira, how he came about this discovery, how the science in South Africa continues to flourish despite the difficulties that they've been having with droughts and the economic difficulties and COVID. You will hear in this conversation how not only he discovered it, how he's created the collaboration, how it unfortunately is spread throughout, and the important science that he's also shared, not with other scientists, but also with the World Health Organization. What a pleasure it is for us today to welcome a world-leading scientist, a geneticist, and colleague at Sutton, South Africa, Professor Tulio de Oliveira. He's a geneticist that has actually been leading the team in South Africa that's made the groundbreaking discovery of these mutants and these variants, which in fact is now spreading across the world and affecting really our concerns. And it's such a pleasure today to welcome him so that we can actually discuss not only his findings, but what it means to us and what it means to this world. But before we start, obviously, as full disclosure, my company, ImmunityBio, is developing a COVID-19 vaccine. And I'm also pleased to say that we will be actually going into the hurricane of these mutations by coming to South Africa. Dr. Tulio, welcome. What a wonderful pleasure to have you.
Yes, good morning to everyone there in Los Angeles. It's middle of the night here in South Africa, but it's a great pleasure to be with you.
You are now known as the virus hunter, and I think a well-deserved credit and acknowledgement to you and your scientific team in South Africa to making this groundbreaking discovery. Can you tell me a little bit what is that about, the idea that you and your team are now being called a virus hunter?
Okay, thank you, Patrick. Yeah, so our team has been working with viruses for many years, for close to 20 years. Of course, we work a lot with HIV, which is a big problem in South Africa. But in the last 5-10 years, I participate in most of the discovery of a lot of the previous epidemics that affect the world, and many of your viewers will remember the Zika pandemic. We also have a number of yellow fever, big outbreaks in Angola and Brazil, and dengue, chikungunya. So one thing that we are learning from the past few years is that emergence of new viruses become quite common, especially as we have degradation of environment and large populations of people in cities and large international travels. Yeah. So what we did, it is that back in January, when we saw the first genome that was released from this virus, the SARS-CoV-2 was released on the 11th of January 2020, we start preparing to set up a very detailed program in South Africa to really follow all the introductions of this virus, but also use that information to try to control outbreaks and to feed back to public health response, which end up us finding a new variant that's much more transmissible in South Africa. But more important, we also help the World Health Organization and international researchers to also find some of the other variants that are circulating in the world. So I think that's why they like to tease us and call us that we are the virus hunters.
Well, I think teasing and actually the seriousness of the work that you do, your group called CRISP, the KwaZulu-Natal group, It's really set the stage, frankly, for what even our country should be doing in the United States of pandemic surveillance and pandemic preparedness. Tell us a little bit more about CRISP, because I think credit really must go to not only the South African scientists, but the Medical Research Council and the innovation support that you've gotten from the South African government that has been so forward-looking in building this organization called CRISP and the ability for you to collaborate. So tell us a little bit about your pandemic preparedness and awareness and genomic surveillance that you and I talk about.
Okay, so around 4 years ago, I decided to step aside of a big Wellcome Trust Center in South Africa to create our own research institute, which we decided to name CRISP, which means KwaZulu-Natal Research Innovation and Sequencing Platform. And our objective was really to kind of try to challenge the status quo. And when I say challenge the status quo, we wanted to create a scientific environment that drive the highest level of research in Africa or in South Africa, and in the same way, bring innovations to the market, but also reverse the brain drain. Yeah. So one thing that we are very interested in is just to challenge a little bit this whole idea that to do high-level science, you have to be associated with international organizations such as the UK or the US, and that you need to be externally funded. And we got major support of our national funders in South Africa, the South African Medical Research Council, and the Technology Innovation Agents to set up a kind of fully automated, basic robotic genomic center that would produce and analyze data in real time. And the objective of that is to focus on our own problems, because that was our only main scientific advantage that we had, is that we knew our problems better than the international world. So we decided to use that scientific advantage together with high-level technology to set up a very detailed genomic surveillance for pathogens in South Africa.
Well, I am incredibly proud to be considered still a South African, knowing that your government now, and I'm a little psychotic between American and South African. So the South African government and the Medical Research Council, and credit to people like Glenda Gray and Slim and Claudina Lotz, who have supported. And it's very hard for people to really, in fact, even understand the level and amazing amount of deep science coming out of you and your group and CRISP and the whole concept of pandemic surveillance for the entire Africa. What you do and what the country is now seeing affects the world. And it's such a pleasure to expose the importance of your work, this little team that has actually impacted, maybe actually changed, hopefully, the trajectory of the entire world. So let's go from there. How did this all start? This began in November, where the outbreak started, and you very methodically, with the support of the South African government, has been following this genomic. So could you just describe a little bit historical backwards of how this started, how you found this variant, and how scary you found how quickly it was spreading?
Okay. So we start doing genomic surveillance in South Africa in February 2020. So every week we collected hundreds of samples and we generated the genome, and we knew which variants were circulating in South Africa. We had around 40, 50 variants co-circulating at a given time. And then around the middle of November, we start getting calls from clinicians, medical doctors in this area in South Africa called the Eastern Cape, or the Nelson Mandela Bay, which was a previous city called Port Elizabeth, which I believe that we were born there, Patrick. Yeah. And and the clinicians there, they were very worried because what they have seen, this area has been the heaviest heated area in the country in the first wave. But what they were seeing infections and number of patients arriving in the hospital in a much faster speed than they have seen during this pandemic. So they contact us. Why they contact us? Because we have helped a lot of hospitals in South Africa with outbreak investigations of COVID. I did, and they contact us and they say like something strange about this virus. Yeah, it is people is presenting far too many of them and quite sick. Yeah, and then we decided to take this hint very seriously, and we asked them to start organize to send us hundreds of samples. At the same time, what we did is to activate our network of labs in the country, which we call the Network for Genomic Surveillance in South Africa, because what we wanted was to sample like close to 50 clinics in that area, sometimes hundreds of kilometers, because we wanted to make sure that what we are seeing in one hospital were representative of the other ones. Yeah. So we got the samples like end of November, and then we prioritized for sequencing. So what we got by 1st of December, we got the first genomes out of the sequencer, and when we analyze, yeah, and I like doing that myself sometimes, we saw this very unusual cluster, very different, yeah, with lots of mutations and very separate from all the other clusters, yeah. And more surprising, every clinic that we sample in that area, it had the same virus, so was not a hospital outbreak, yeah. Then straight away, I went to the chair of our ministerial advisory committee, Professor Salim Abdul Karim. He is our kind of Tony Fauci of South Africa. He has a very similar position as Tony Fauci in the US, and went to him to present and ask permission to him to present also at the World Health Organization Evolution Working Group, which I'm part. And so we did that very early in December. And that's what led also the identification of other major variants in the world, such as the British one. Yeah. So I think from us, we're more like following a very serious collaboration with clinicians and following their advice and then acting very quick, both on producing and analyzing the genomic data, but then communicating with our government and the international scientific community.
So what you just described is that South Africa, in a funny way, has taken the world's lead in leading the science. It's all the way through the genomic analyses. So you basically have taken absolute advantage of the advancement in science that we understand today, where we can genomically analyze. And I don't know of any other country that has actually taken that lead, looking at the evolution, the life evolution of this virus. As you said, Professor Slim and Glenda Gray and Claudine Lutz, that combination of supporting you and the fact that you are now probably one of the key players in the collaboration. I'm not proud of the fact that it came from Port Elizabeth, but I also understand. I grew up in Port Elizabeth and the townships there in which the people live in the very difficult conditions and some of the immunosuppressed ill patients. So I think I felt so strongly, Tulio, that people recognize the credit when we talk about the 501Y, and we'll get more into the details of these variants, the 501Y variant, so to speak, version 1 in the UK, is in essence being the alarm bells that you sounded, your team sounded, and UK confirmed it, and then you found the version 2, which is a very scary variant, which we'll get into, of the 3 mutations rather than just the 1 mutation. Before we go there, let's talk a little bit about the status of the country, because as you began to sort of see this from a clinical perspective, the spread from the Eastern Cape, people may not know the geography of South Africa, and maybe as we get into the slides, you'll sort of show us a map of the enormity and the spread, not only up and down South Africa, but into Africa and then the rest of the world. Could you talk a little bit about that? How is it now in South Africa, and how is it spread?
Okay, so it's easy to compare what happened in the US. Yeah. So, for example, our first wave in South Africa was very similar what happened in United States of America. Yeah, it started in a state like such in the US, in New York, in South Africa, was in the Western Cape, in Cape Town, also very touristic town, and start slowly moving from state to state to state, okay? What in South Africa we call provinces, yeah? But the second wave in South Africa with this much more transmissible variant, that didn't happen. It is starting one geographical area, and within like a few weeks just spread everywhere by the coast really, really, really fast, yeah, and then enter the center of the country, and now it has spread also to neighboring countries. So the speed of diffusion, that's what you call scientifically, this variant, was extremely high, very, very, very fast, yeah, and we haven't seen that in the first wave. And so what we start, to be honest, we get a little bit scared, because like today we just I just deposit another 100 genomes or 120 genomes in the public database from KwaZulu-Natal, and from the 120, like 116 were this variant, yeah. And like a month ago, in KwaZulu-Natal, we had like maybe 40% this variant, yeah. So the rate of spread is phenomenal, and the way as it gets to completely dominate, almost like displacing all the previous lineages that exist in the country.
That is very frightening, because sadly, Tulio, you and I, we talked about this. This is almost inevitable evolution. As we talked about, the virus has now found a path in man. It's used the man as the host. And in order for it to survive, and it's this intelligent machine, it will adapt. It will adapt and adopt and mutate. The speed of this mutation is what I think has surprised us, and thank God you discovered it early. But I think the other thing that's really concerning is also the speed of multiple mutations in the same virus. And we'll talk about the implications of that and how it affects convalescent serum, and how it affects maybe the antibodies, and how it affects into the vaccines. And we'll talk about a little bit about these variants that are growing and fast, is all in this receptor binding domain and the spike protein, which is where the virus attacks to enter. So it's what you're saying then is not only the rapid mutations, multiple mutations, but increasing transmissibility and therefore infectivity. We'll talk a little bit about how it affects our treatment. So speak about your concern about the transmissibility and the multiple mutations, and the fact that this is at the spike level, and the lay people don't fully understand what spike means. But
Okay. Let me explain in simple terms. One thing that concerned the process that we call convergent evolution, what it means that we had these mutations appearing independently in 3 different geographic areas in the world on completely distinct lineages of SARS-CoV-2. So, for example, the virus that we found in South Africa has this very important mutation, the 501Y, that increased transmissibility, which this mutation also emerged in another independent lineage in London, which that lineage, what they call the B117, it now have been found in 50 different countries, because London is much more connected internationally than South Africa. Yeah. The same mutation, the 501Y, was found in travelers from the Amazon that came from the Amazon in Brazil to Japan. Yeah. And so again, completely independent. And then what got even more scared is that not only this 501 mutation, they also sometimes have what you call a nasty brother, yeah, that's very close by, which is another mutation that's called the 484K. And these mutations seem to really be escape of antibodies. Yeah, what it means that maybe the body defense will be quite weaker against this virus. And that mutation emerged in the virus in South Africa in combination with the 501Y, and also the virus in Brazil. And we are not going to be surprised in the next 2 weeks we find like 10 of these variants, because if that can emerge in South America, in Europe, and in Africa, why will not emerge in other places that haven't controlled the pandemic, such as United States of America?
So I can explain this to the public. What you were actually saying is even scarier, that this was not a transmission possibly from South Africa. This is what you call convergent evolution, meaning that the virus itself, as an intelligent machine, adapts. And now you talk about the bad brother or the nasty brother. So, and we will talk about it, you and I have been talking about it in great detail, and we shared with you our molecular dynamic analyses, where if I would describe to lay terms this virus that RBD or spike protein that enters into the ACE, is you consider it a shoe or a high-heeled shoe with a heel, an arch, and a toe. And the 501 is the mutation at the heel. But that heel was always tight to the ACE2 receptor. So that was the first variant that the UK, and in fact you alerted that. Then you discovered the toe, which is the 484. Now when you have the heel and toe combined, that changes the shape. You now have a shape changer, and that is what is now scary, because those, you think, mutations not only is convergently developing, will develop across the world, but and we'll get to that in more detail as we discuss this together, what it does with regard to convalescent serum and vaccines and even the current treatment we have. So this intelligent machine is remarkable, and I've been saying, Tulio, your variant, the 501 versus V1 and the 501 V2, should really be named now 484 V1, because that is what I believe you as a group have really changed the awareness of this world. Maybe we can talk a little bit more of that scientifically, because I think people will understand what you call this triple mutation and how does this variant work, what does it do, and what does it do to the treatments that we have. What does it mean that you have a shapeshifter, a conformational change in scientific lingo, or the change of the lock and key in the language of a layperson? Could you just talk a little bit about that?
So what we found is that these mutations, as you described, the heel, the arch, and the toe, they make this lock much stronger. Not only they make much stronger, but the virus can enter easier to the body, but then they will potentially, and we have find evidence, they will block the antibodies that would stop that to happen. So we may be ending up with viruses around the world that are much better adapted for transmission between humans and to evade the immunological machine of the body, that's kind of the fighters or the soldiers of the body, to affect that. Of course, this is worry, because one of the things that the vaccines try to do is to mimic or stimulate the defense of the body.
Tulio, thank you for describing that thing about multidrug resistance and the mutations that you're working all your life there in Africa and South Africa. From my perspective, this is not unique biology in the sense that in cancer, we see these mutations happening and they become, you actually generate a mutation in response to the treatment to become resistant to that treatment, and that's how cancer evolves, so that you ultimately get to sadly, no treatment exists unless your immune system kills it, i.e. the T cell, and we'll get to that. When you get to multidrug resistance, whether it be HIV, malaria, TB, that's the same thing happens. These biological systems have evolved almost inevitably to mutate, to adapt to the treatment that we as human beings induce. So it appears that this coronavirus, which is already deadly, has done exactly that, is mutated incredibly fast. Will you now just address a little bit, and I know this is very scary information, but it's important coming from the scientists that have done the work, yourself and Alex and Richard. And we've had the privilege of actually seeing your science before it's even published. And I assume that the paper is about to be published in Nature somewhere soon. Could you describe and talk a little bit about how this variant, what we call now, there's multiple variants, but we'll just call it the 484 variant, your variant, the V2 variant, same number, with this multiple mutation of the toe, how it compares when you tested the convalescent serum against that. Will you describe and how it grows differently? You already talked about how it spreads. So if you could just describe your findings that are basically being published this week or next week.
Okay, so of course that is not just our findings, yeah, and it's what we called like that all the evidence is pointing the same direction, yeah. So once we highlight these mutations, the 501Y and the 484, yeah, hundreds of scientific groups around the world start doing experiments for test these mutations, including also your own company, Patrick, also modeling that in the molecular dynamics. Yeah. And one thing that's becoming really evident from many lines of evidence, what it means from protein structure, how the virus bind and antibodies cannot get into the space, from what you call pseudovirus. They have a fantastic work that was published last week from Jesse Bloom lab that's in the Fred Hutchinson in Seattle, showing that this mutation, the 484, will be the most important mutation to escape neutralization. They also had another fantastic group in Italy that keep exposing the virus to convalescent plasma. And around 80 days later, this exposure, it developed the 484 mutation and escaped the neutralization. But what was interesting, it is what we call like reproducible science or high-level science, when many different groups, independent in the world, using different technology, can come to a very similar conclusion. And then the main take-home message is that if we leave this coronavirus circulating for so long at such a high level, that this virus will outsmart us.
It's a very, very, very disconcerting because it's basically man against virus. It's virus against man, almost. Not I'm going to the level of existential, because we're going to find a way to win this war. So let me just interpret what you just said again. What is really important and exciting is that really completely independent, high-level, credible scientists have not only corroborated, but actually independently discovered the same path. On the one hand, the Fred Hutch group showed using the pseudovirus that the E484 actually is important. I think the most scary and concerning one is a group also in Italy that showed that when you put viruses in convalescent plasma, they themselves independently evolve to super select the 484, which becomes what you call this escape mutant. And then finally, all this work you had already earlier confirmed in December when we did this combination. And when you put these combinations together, as you said, not only does it lock tightly and in effect higher, it shapeshifts, it conformally changes. Could you describe a little bit the experiments you did there? The growth, the syncytial growth of those cells. And then we'll talk about the slides, which I saw, which was very frightening, of the virus not being affected by first wave plasma.
Okay, so I can describe the part of the experiment. So what we did quite early, the basic, a day after we discovered this variant, that we discussed with the chair of our ethics board, about linking to another group in the same building as us, from Professor Alex Siegel, and then we submit and we got permission from our ethics board to give them virus isolates or samples from individuals, so they could grow that in the lab, and it was quite phenomenal, because They got the virus like basic 10 or 15 of December. Yeah. And that when the holiday season started in South Africa. But what this group did that they just didn't took any holiday. They just on Christmas Day, on New Year Day, they were there in the lab because this is very advanced labs. It's what you call a P3 lab. It's a highest security bio lab that you have to go like even with respirators, you look like as a kind that you are in the space, yeah, with a suit, yeah. So what they do, they have these different cells, yeah, lung cells and lab cells called Vero6 that they go and they infect them with the virus. And normally it take around 2 weeks or to the virus it start to have enough titer to grow. After the virus grow in these cells, what they do, they put a kind of membrane on top, so the virus cannot they cannot spread to the other side. So what they do after that, they can count. They use these very advanced microscopes, and they can count the number of particles of the virus and what they call the colony-forming units. Yeah, and so because that they know how many virus will circulate, will grow without any antibody, and then what they do, they start titrating the antibodies of the convalescent plasma, and they do that in a combination like a dilution of 1 to 100, 1 to 200, 1 to 400, 1 to 800. It's a very methodical process that you stay exposing the virus that's grow to different concentrations of the plasma or the covalent serum, yeah, and see and then counting how many virus get neutralized, yeah. But what you have to do that not only with the virus that of this new variant, but you also have to do that with the virus that was previous circulating, yeah. And then you measure the difference between the two, and what the difference came is quite striking. Is that the previous variants that are circulating could be well neutralized, and the new one was very weakly neutralized. Yeah, and some individuals would treat, or the plasma of the individual would treat this virus as naive person, as someone that had never seen the virus. Yeah, what's quite worrying because that has major repercussions for potential reinfection, but also to some of the component of the response of vaccines.
Well, what you just brought up here, again, another level of seminal work. One, at first, it shows the collaboration, the importance of high-level scientific collaboration in the same building. You and I talked about that in this, and again, I'm so proud of the country and yourselves. But the profound implications that your work now implies and have demonstrated is that patients who were previously infected, their convalescent serum may not protect them from this next wave of this virus. That's number one. Number two, the potential for them getting reinfected is therefore potential. And number three, the monoclonal antibodies that are being developed or are in use, and EUA may not be effective, the Regeneron, Eli Lilly, against this virus. And number four, we don't know yet whether the vaccines that are focusing on spike may be infected. So there's a huge amount of implications up and downstream. So without creating this fear, we obviously need to learn this. But I've also understood that you've discovered a patient that was infected with the first wave and now reinfected with the second virus. Could you talk a little bit about that patient, if I may?
Okay, so first, that's what you highlight there. That's the excitement of science. Each question that you answer, it normally comes 4 or 5 different questions to answer after that. Yeah. So all these questions are extremely important. And again, we are working with a big consortium of national and international scientists to try to answer them very quick. Yeah. Yes, we do have a number of patients. I think that we have 5 by today, we confirmed 5 different patients that were infected with um, a previous virus that was around like 5 6 months ago, and they became reinfected with this this new variant. Yeah, and and that of course it is worrying. Yeah, we are still going quite methodically through the data, because one thing that we still need to know is that, okay, these 5 patients, that a rare event, or is a common event. Yeah. So one thing that we know is that they can get reinfected with this virus, but we have to understand what is the how common this is, because so far everyone assumed that reinfection was extremely uncommon. Yeah. And anyway, to prove reinfection is quite challenging. You need to have a very good, well-functioning genomic surveillance program, because you have to have a genome of the virus that infected the person 6 months, and another one 6 months later. So you have to really be good to generate data and have good sample control. And we also have to do the human marker, make sure that the samples are from the same individual. Yeah. So that's the first question. How common is reinfection? We know that this virus can reinfect people, but the next question is how common. The other next important question is that, is the reinfection with less severe clinical symptoms or similar clinical symptoms? So at the moment we are working on that, and so far it seems that maybe the reinfection may be quite similar or slightly less clinical symptoms, but it's early day. We have to go through all the clinical file. But one thing that we noticed that got us quite worried, yeah, was also the psychological effect, because these individuals, they are mostly healthcare workers, yeah, and one of them had to be hospitalized from most, like, not only from the symptoms, but really nervous about being reinfected and bringing this virus back to the family, because they assumed that now was naturally protected. And that's something that we worry a lot. Yeah, our healthcare workers, not only in South Africa but around the world, that they are really stretched to the limit. Yeah, and they don't need like some more fear of reinfection with a variant that may have evolved to make that more often.
You know, what you raise again every time is exactly what when you do good science, one question gets another question or many other questions. But what you just said in your last statement is a little, very actually even more disconcerting. So this patient was a healthcare worker, as I understand it. She got infected with the first wave, recovered, completely negative, went back to work, got reinfected. But now with the second wave, you don't know whether she had a vaccine or anything in between. But what you're saying is that she got reinfected by the second wave, meaning that her whatever antibodies that she had from the first wave didn't protect her. Is that what the implication of that? Even though it was just one patient now at this point.
Yes. That but that we also know from the previous variants, that some individual will have, after many months, the antibody levels will decrease, and then there is potential of reinfection. One thing that I think that especially healthcare workers, they get very nervous. Yeah, is not only about themselves, but also to bring the infection back home. Yeah, and infecting the families. Yeah. So I think that's one thing that add a lot to the anxiety of healthcare workers. Not they are in this terrible situation that every day they are seeing people like desperate need the oxygen and dying in the ICU wards. Yeah. But they also worry about themselves and about the families. So if some healthcare workers, if they have been, and it's quite common that this virus in certain hospitals, not only in South Africa, but across the world, would have infected 20, 30, 40% of the healthcare workers, extremely transmissible in a hospital environment. Yeah. But then if you have passed through that, yeah, and you got sick, and then, okay, you thought that now you're immune, and then you get in that situation again, it's very, it's very disconcerting, and it's a very nervous situation to be. So that's why we think and we really hope that these reinfections are a rare case. We have our fingers crossed that they are not as normal as we expect, because we do worry about the frontline healthcare workers. Yeah.
So, Tulio, one of the premises of the Second Opinion at LA Times is to provide hope. What we've been talking about is really, really, really scary. So, in your opinion, as we move forward here, knowing that potentially that convalescent antibodies don't work, protective antibodies aren't protective, monoclonal antibodies may not be currently protective, vaccines that just focus on spike may not be protective as an antibody. What do you think is the solution here? Where do you think we're going with this? What is the hope? What's the hope for the future? And we need to move fast not only for ourselves, but for the world, frankly, not only just in South Africa, where it's now rampant. What do you think is the hope we can provide to the world of where we should go now that we know that the antibodies, the shape-shifting happens?
Okay. So I am an extremely positive person, and I have a lot of hope. Yeah. So one thing that we can see, it's what we hope that increases a little bit of shifting of the globe in certain countries, and we hope also United States of America taking more serious this virus. Yeah. Because one thing is that it's our utmost importance to try to these three variants that we describe here to be a basic wake-up call to the world and government and public health officials to take very serious and try to decrease transmission to almost zero. Yeah, it's also a wake-up call to very quick increase the number and the breadth of vaccines that have been developed and distribute them as quick as possible. Because one thing that we know is that even that some of these variants may be less neutralized by antibodies, the vaccines, a lot of times they have broadly neutralized antibodies, and they will act in many different areas of the virus, and then also have the other part of the immune system as the T cells that could also hit on this infection. Yeah. So also increase the delivery of vaccines and bring more potent vaccines, try to decrease transmission, and also realize the world that we are in a global pandemic and we need a global response, because just controlling infections in your own country or not, it means that this virus spread very fast. For example, the variant that was found in the UK, the B117, now is in 50 different countries. The South African one, by this evening in South Africa, when you got a look on the data, was in 16 different countries. Yeah, and so these lineages, they spread very fast. So the world has to try to focus on controlling transmission everywhere, and also do that not only in the rich countries but also in the developing and in countries. So to try to protect the whole community. So I really hope that's a wake up call, and that we can really now use the weapons that we have to control this pandemic, which we have many of them. We just have to use them more effectively and more focused.
Let's close with this one concern about the cold chain and Africa. And that really is my personal concern, right? Developing countries require, again, to talk about thinking out of the box, is to develop an oral vaccine or something that we did for polio, where we had a sugar tablet under the tongue. What's your thoughts about that? Because this minus 80 degrees mRNA, I get that, it's new technology. But I don't see that being a practical approach for poor countries in Africa.
Yes, it's absolutely not a practical approach. For example, in my lab, we do have many minus 80 freezers, but that's extremely unusual. Yeah, and to have that in South Africa or in Africa. I must also say that in South Africa at the moment, we have a massive problem with our energy supply. So every day we run out of electricity for 2 to 4 hours a day. So even any kind of refrigeration, especially in rural setting, may be challenging. Yeah. And I would agree with you that a vaccine should be effective in developing countries, but also in developed countries, because it would be much easier to administrate. Would be fantastic if it do not need cold chain and also do not need injection. Yeah, because it would be much better that could be taken as a pill, or as you say, as the polio, which is a little drop in the mouth. So of course, in South Africa is by far the most developed country in Africa. Yeah. And South Africa, many of your viewers may not know, but it's even part of the G20 nations, the 20 most developed countries in the world. Yeah. And we wouldn't have the facilities to distribute a vaccine that needs -80 or even -30. That's the second level of ultra deep freezer. Yeah. And this would be much less available in the other countries in Africa, but also in Southeast Asia and also in Latin America. So I do agree with you that the technology have not only to develop vaccines, but also have to use technology to make them easily to distribute.
Well, Tulio, I can't tell you how grateful I am for you to present to the Los Angeles Times your insight. I'm also can't tell you how grateful I am to you and your team for really making not only groundbreaking, world-shattering, enlightening science that's going to affect the world. And I'm also can't tell you how proud I am of the South African research community and the government that supported you. And thank you for being with us today. As I said from the beginning, your work and your scientific team and the science that South Africa has performed is hallmark and will have major impact on our fight against COVID. So thank you for your time. I really appreciate this conversation.